Okay, hello, assalamu alaikum. Yay. Okay, okay, good. So today we're going to do bounds, very simple topic for GCSE Edexcel. So just stay tuned. So question 1, we have m is equal to root of s over t. Okay, where s is equal to 3.47. T is equal to 8.132. Correct to 4 significant figure, the other one's corrected to 3 significant figure. By considering bounds, work out the value of m to a suitable degree of accuracy and give a reason for your answer. Okay. So let's find the upper limit and the lower limit. So the upper limit for s is 3.475. The lower limit is 3.375. If I'm not wrong, is it 3.375? 3.465. Okay. T maximum should be 8.1325 and minimum is 8.1315. So yeah, so that's it. So let's search for the upper bound of m. And now for you to get the upper bound of m, you normally take the upper bound of the s over the lower bound of t. So square root of upper bound of 3.475 over t, which is the lower bound, so 8.1315. So just like I've said, s upper bound over t lower bound. So let's see how much it's going to give us. So square root of 3.475, square root of 3.465. Okay, so this gives you 1.8641 over obviously 8.1315. Let's see how much it gives us if you divide it by that. It's going to give us 0.22924. Let me write as much as possible. 0.229248624. Okay, for the lower bound, obviously for the lower bound of m, you normally take the lower bound, that is the square root of s lower bound divided by the t upper bound. So the lower bound of s is 3.465, square root it over the upper bound of t, which is 8.1325. So let's see how much it's going to give us. So square root of 3.465 divided by 8.1325 is going to give us 0.228890. 0.22890 383. Okay, now we need to work out the value of m to a suitable degree of accuracy. Now if you look at this, okay, this so if you just look at it of this one and this one, okay, which one, when you round it off, it gives you the same answer. So if I do two significant figure, okay, to do this significant figure is going to give me 0.23. If I do this also to two significant figure, is also going to give me 0.23. So the answer is basically 0.23. As simple as that. So that is the answer. Because if you look at it, if you maybe round it up to maybe 3, it's going to give you 229. The other one is going to give you 229. By the way, you can also round it up to maybe, let's say, 229. 229 is also good. Okay, 229. Yeah, 229 is at least understandable as well. So something like that. Okay. Question 2. Find the value of the reciprocal of 1.6. The reciprocal of 1.6. Reciprocal of 1.6 is 1 over 1.6. 6. If you want, you can multiply by 10. Multiply by 10 is going to give you something like 1 over 160. Sorry, over, so this is 10 over 16. But why should I do this? Just use the calculator. 1 over 1.6. So 1 divided by 1.6 gives you 0.625. That is your answer. Or the other question just rounds a number x to one decimal place. The result is 9.8. So it just rounds a number x to one decimal place. The result is 9.8. Write down the error interval for x. Okay. So now the accuracy is around 0.1 because it's one decimal place. So if you multiply by half, it's going to give you 0.05. So the answer that you have, which is 9.8, you do plus or minus 0.05. Okay, so which will give you, I think if you add 0.05, is going to give you 9.85. If you minus 0.05, okay, it's going to give you 9.75. So in short, x should be greater or equal to 9.75 but less than 9.85. Yeah, as simple as that. Question 3. The petrol consumption of a car in liters per 100 kilometers given by the formula petrol consumption is equal to 100 times number of liters of petrol used over number of kilometers traveled. Nathan's car traveled 148 kilometers, correct to 3 significant figures. The car used 11.8 liters of petrol, correct to 3 significant figures. Nathan says, my car used less than 8 liters of petrol per 100 kilometers. Could Nathan be wrong? You must show how you get your answer. Okay, so just like we said, you must show how you get your answer, by the way. Now this one, we'll search for the maximum consumption. Okay, maximum consumption. But now, before that, you need to know the maximum, then obviously. So normally you take 100 times the liters, which is upper, over number of kilometers or distance, lower bound. So number of liters of petrol used, upper, over the distance covered, the lower bound for the distance covered. So for now, let's see upper bound for the liters used is going to be 11.85, because if you look at it, 11.8, so the maximum is going to be 11.85, the minimum will be 11.75. So I'll take 11.85. So the distance covered, distance is if you look at it, the upper, the real distance is 148, so the lower is supposed to be 147.5 and the upper is supposed to be 148.5. So for now, we'll use 100 times 11.85 divided by the lower, which is 147.5. Let's see how much it's going to give us. So 100 times 11.85 divided by 147.5, which gives you 8.033. Okay, 8.034 there, 8.034. So your answer is 8.034. Okay, that's the number of liters per 100 kilometers. So is it correct? No, it's not. Okay, so can he be wrong? Yes, he can be wrong, because the maximum consumption is 8.034, which is greater than even the 8 that we have here. So yeah. Okay, Jackson is trying to find the density in gram per cubic centimeter of a block of wood. The block of wood is in the shape of a cuboid. It measures the length as 13.2 centimeter, correct to the nearest millimeter. The width as 16.0 centimeter, correct to the nearest millimeter. The height as 21.7 centimeter, correct to the nearest millimeter. He measured the mass as 1970 grams, correct to the nearest 5 grams. And by considering the bounds, work out the density of the wood. Give your answer to a suitable degree of accuracy. You must show all your workings and give a reason for your final answer. So let's write this. So you have length, which is 13.2. We have width, which is 16.0. We have height, which is 21.7. And let's find now the upper bound and the lower bound of each. So yeah, so the upper and lower. So the upper bound of 13.2 is 13.25. The lower bound is going to be 13.15. So just imagine if this is 13.2, so obviously you'll have 13.3, and the other one is 13.1. So in between 13.1 13.2 you have 13.15, and in between 13.2 and 13.3 you have 13.25. So that's why I've written it something like that. So hopefully you've understood me. So you have 13.25 and 13.15. So the upper bound of 16.0 is 16.05, and the lower bound is supposed to be 16 point is it 16 point or 15.95? Because if you look at it, this is 16.0. The upper bound obviously no, then let's say 16.1, and then you have 15.9. So obviously 15.95, and the other one is 16.05. So it's very simple. Just need to just visualize. Now obviously this is the lower bound is 21.75, and the upper bound is 21.75. The lower bound here is supposed to be 21.65. Now volume, there's the upper and there's volume lower. So volume obviously length times width times height. So the upper bound for the volume is going to be 13.25 times 16.05 times 21.75. So you take the upper, because all of these are upper, so none of them are low. So you just take this. So, and let's see how much it's going to give us. So 13.25 times 16.05 times 21.75 is going to give us around 4,625. 4,625.409. 0.409375. I like writing. I like to write a lot of numbers so that I don't get an error afterwards. So what about the volume of the lower or the lower upper? You have upper and the lower bound. Now the lower bound obviously is going to be whatever remains here. So here, so you multiply all of this. So you take 13.15 times 15.95 times 21.65. Let's see how much is it going to give us. So 13.15 times 15.95 times 21.65 is going to give us 4,540. 4,540 point, a lot of numbers, 925,125. Let me just write them. Now those are the volumes. Okay. Now what if you know in a there's mass, density, and volume. Let's look at mass first. The mass is basically 1970 gram. Okay, since it's rounded off to the nearest 5 gram, so its maximum or its upper, okay, mass upper is going to be half of 5. Okay, since it's 5, a half of 5 is 2.5. okay, half of 5 is 2.5. So your maximum is going to, your upper bound is going to be 1970 plus 2.5, which is now 1972.5. The lower one is supposed to be minus 2.5. So 1970 minus 2.5 minus 2.5 is going to give you 1967.5. So 1967.5. Okay, now let's see the density upper. So density upper is going to be mass upper over volume lower. So the mass which is upper, you take going to get 1972.5 divided by the volume, or the lower bound for the volume, which is this one. So divide by 4540 point, maybe write 925. The least I can do is that. So 1972.5 divided by 4540.925 is going to give me 0.43438. 0.43438. There's also other numbers, but let me just write it here because of the space. So I'll have 0.434382862. So mass lower or volume upper, you take the mass which is lower, 1967.5 divided by 4625.409, maybe. Let's see how much is it going to give us. 1967.5 divided by 4625.409, get 0.42536. 0.42536, and it's continuing. Okay, you can get 7789, 7789. So it's still continuing. So if you look at it, which one is the better version? If you round it off, because the question is asking you to show you all your working and give you answer to a suitable degree of accuracy. Now if I look at my answer, the best one, the highest level of degree, is to 2 decimal places. Yeah, to 2 decimal places. This one to 2 decimal place, and also this one to 2 decimal place. Because if you round that to 2 decimal places, it give you the same thing. It's going to give you 0.43, and this one will also give you 0.43. So that is our final answer, 43 grams per cubic centimeter. Now, Sally used her calculator to work out the value for number y. The answer on her calculator display began. Complete the error interval for y. So if you look at this, the maximum is 8.35. Obviously, the minimum is going to be 8.25, but just write that number line. So let's say if this is 8.3, this is going to be 8.4. This is 8.2. In between, we have 8.25. And in between here, we have 8.35. So it's just 8.25 and 8.35. Simple answer. Okay, D is equal to U squared over 2A. U is equal to 26.2, correct to 3 significant figures. A is equal to 4.3, correct to 2 significant figures. Calculate the upper bound for the value of D. If your answer correct to 6 significant figures, you must show all your workings. Now let's say you have U and A. So U and we have A. Okay, so let's find the upper and the lower. Okay, the upper of U, because U is 26.2, the upper of U is going to be 26.25. The lower of it is going to be 26.15. Just imagine this again, this scenario where you have 26.2 and you have 26.3, you have 26.1. Obviously this one is going to be 26.15 and this one is going to be 26.25. For A is going to be 4.35, the lower is going to be 4.25. Also imagine that where you have 4.3, 4.4 and 4.2. This is going to be 4.25 and this is going to be 4.35. So simple. So calculate the upper bound for the value of d. So if you want to get the upper bound for the value of d, you normally take u squared. So you take the upper, divide by 2a, which is the lower. Okay, so let's take upper of u squared, which is 26.25 squared, divide by 2a, which is 2 times a, with the lower of a. So basically take this, and I took this. So 2 times 4.25, 26.25 squared, it's going to give you 689.0625, divide by 3 times 4.25, so which is going to give you 8.5. Okay, so 26.25 squared divided by 8.5 is going to give you 81.066. That you've been told you have 81.06617,647, but to use 6 significant figures. So this is 1, 2, 3, 4, 5, and 6. So in front of 1 we have 7, which is greater than 5. So you'll round up 1 to 2. So you'll have your answer to be 81.0662. Correct. So that is our answer. Okay. The lower bound for the value of d is 78.603. 6003, correct, to 6 significant figures. Considering bounds, write down the value of d to a suitable degree of accuracy. You must give a reason for your answer. Everything is usually a reason. You're here for a reason. So yeah, so d, the lower bound for d. So you have the lower bound, and so let's say the lower bound is 78.6003, and the upper is 81.0662. Now if you look at it, if there's a need for you to round off this lower and this upper so that you can have same answers. So the only way is just to round it up to one significant figure and also one significant figure, because if you round this up to one significant figure, it's going to give you 80, and also this one is going to give you 80, and therefore the value of d itself, it should be 80. And the reason is because the bounds are same. The bounds are same when rounded up to the nearest 10 or one significant figure. Question 7. The length of a pencil is 128 millimeters. Correct to the nearest millimeter. Complete the area interval for the length of the pencil. So again, we have something like this. We have 128, then we have 128.5. Obviously this is 129, this is 127, so this one is going to be 127.5. so the area interval is 127.5 and 128.5 as your upper bound. So d is equal to 1 over 8c cubed. C is equal to 10.9. Correct to 3 significant figures. By considering bounds, work out the value of d to a suitable degree of accuracy. Give a reason for your answer. So this is as simple as possible. This can be simple as possible. So obviously we can first, let's see c, which is 10.9. so obviously we know the, what do you call it, the upper and the lower. So this is 10.9, this should be 11, and this is going to be 10.8. so right here we have 10.85, and right here we have 10.95. okay, so basically your upper for that is 10.95 and the lower is going to be 10.85. So let's search for now the upper for D. D upper is when you take 1/8 times the upper for C, which is 10.95 cubed. So 10.95 cubed times 1/8. 1/8 is just a constant, so it gives you 164.1165. 164.1165469. You can write as many. Then we have D, the lower. So the lower is supposed to be 1/8 times the lower, which is the lower of this, times 10.85 cubed. Let's see how much it's going to give us. 10.85 cubed times 1/8 is going to give us 159.6611. 159.6611,406. Okay, so that is that. Okay, now let's now round it off. Which one, if you round it off, should give you same answers. So that's why I'm using this pen. So if you look at it, if you do one significant figure, it won't give, it will give you 2, but the highest one I think is to 160. The other one is also 160. So I think only for me is two significant figures, or to the nearest let's round it off to the nearest tens. That is to two significant figure. So that it gives you 160, and this one will also give you 160. So, and therefore this is your answer. Why? Because they should be equal, because they are equal when bounds are rounded up to, or rounded off to the nearest tens. But you can also write to three significant figures. It's also correct. Question 9. The time period t seconds of a simple pendulum of length L centimeters given by the formula t is equal to 2 pi square root of L over G. Okay, let's do this question 9. The time period t seconds of a simple pendulum of length L centimeters given by the formula t is equal to 2 pi root of L over G. Now KT uses a simple pendulum in an experiment to find an estimate for the value of G. Here are her results. L is equal to 52.0, correct to three significant figures. T is equal to 1.45, correct to three significant figures. Work out the upper bound and the lower bound for the value of G. Use pi to be 3.142. Now, for before we do this, we need to make G the subject of the formula, because most probably is asking about G. Okay, now for us to make G to be the subject, obviously we need to divide by 2 pi. So let's say, let me just write here, T is equal to 2 pi root of L over G. So you need to divide by 2 pi, and after doing that, you cancel out this 2 pi's and you just remain with L over G. Then for you to remove the square root, you square and you square on the right side also. So you're going to get t squared over 2 pi squared, that is 2 pi squared, which will be 4 pi squared. So it's going to be 4 pi squared is equal to L over G. Now we can do it this way. Okay, so we can write G over L so that G goes up. So this will mean that 4 pi squared will go up and the t squared will also go down. So let's remove the L, and let's remove the L, and therefore G is going to be equal to let's say 4 pi squared L over T squared. So that is the formula for G. Now, after knowing the formula for G, obviously this one's become easy. So let me write L and let me write T. So upper bound and there's lower bound. So the upper bound for L is 52.05. And that is, if you look at this, if this is 52.0, this is going to be 52.1. This is going to be 51.9. Obviously, this one will become 51.95. And this one will become 52.05. So the upper bound is 52.05, lower bound is 51.95. As for the T also, if you look at T is 1.45, so 1.45. So this is going to be 1.46, 1.44. The lower bound is supposed to be 1.445, and this one will become 1.455. So the upper bound for this is 1.455, and this one is going to be 1.445. Very simple. Okay, after knowing that, then it becomes easier. So using this formula, so let's say if you want to get G upper bound, what do? We take this one, upper bound, divide by T squared upper bound. So let's just do this. So you do 4 times 3.142 squared, okay, times L, and our L is basically 52.05, the upper bound for it, divide by T squared, but lower bound, sorry, this is supposed to be T squared lower bound upper, divide by lower. So 1.455 squared. So let's see how much it's going to give us. So 4 times 3.142 squared times 52.05 is going to give us, then divided by 1.455 squared is going to give us 970.8834. So let me just write it, 970.88345. Okay, but what if you're asked to now search for the G lower bound? So it's going to be 4 pi squared L lower bound over T squared upper bound. So just do the same. So 4 times 3.142 squared times L lower bound. L lower bound is 51.95, divide by T squared upper bound, T squared upper. This is 1.45. Sorry, I think I did something wrong. So this one we said is lower bound of T squared. So I'm supposed to write 1.445. So the answer isn't this. Sorry for that. 4 times 3.142 squared times 52.05 divided by 1.445 squared is going to give you now 984.36779. But for this one, T squared upper bound, so it's going to be 1.455 squared. So let's see how much is it going to give us. 4 times 3.142 squared times 51.95 divided by 1.455 squared. So that gives us 969.01816, and there's still continue. So but now what's the question, by the way? You haven't seen the question. The question is asking us to work out the upper and lower bound for the value. So the upper, what you told to nothing. So the upper is basically this one, 984.367 maybe 8. The lower is 969.0182, maybe. So those are your answers. Last question. Freya writes down the value of x correct to one decimal place. She writes x to be 6.4. So one decimal place, complete the error interval for x. So this is 6.4. So you write 6.5, 6.3. So in between 6.3 and 6.4 is 6.35. And in between 6.4 and 6.5 is 6.45. And therefore our answer is going to be 6.35, but less than 6.